particularly um okay, we are starting the recording now, so the meeting officially starts now. So I was asking, do you is there anything that is particularly that stood out particularly that was particularly challenging, or anything you'd like us to discuss before we continue?
I've not really, I've not started the practical aspect, so I believe that once I start there, I might face some challenge.
Mm,
But for now, I'm just reading through the material first.
okay, and it's also quite important that the material is fully consumed before the next session because, like after today, by tomorrow, later tomorrow, we will be having materials that have accumulated from today. So
Yes,
most times, if you are not able to fully consume the materials from the former lessons, when this one meets up with it, the chances are that you would end up abandoning some things that you're supposed to fully
consume.
consume. So
I
please
get you.
bear that in mind.
Okay.
Okay, that being said, today there are two things that we're going to be looking at. We're going to be looking at classification. Last week we did a regression task using machine learning. Today we are going to be looking at classification using machine learning. Then before that, I'm sorry, this particular session that I'm going to do now first before we start was supposed to have come next last week. Now, immediately we start our practical sessions, we're supposed to host them on Git. Um, are you familiar with Git? GIT, GitHub?
GitHub. No, I'm not
Yeah.
familiar with it.
Okay. All of our projects, all of the one of the things you're supposed to do is to develop and grow a GitHub profile. At the end of this session, you're supposed to have a number of projects in your Git account, maybe
I think you made mention
between
of something like that the last
y-
lesson.
yes, yes. So the first thing before we start today's lesson is supposed to be a full day's lesson, but I think we are kind of pressed for time to be candid. So I would try to see if I can squeeze in two sessions into today, which is the classification project and also Git using Git. So I'll start with Git. It will be a very, very practical project. We're not going to, I would attach materials that we would use, but let me start a Virgin account. I already have a Git account. So if I go through the normal route, you would see, okay, let me just go through the normal route. So you see how my GitHub account is, just to give you a glance of what GitHub is and how it works. Now, GitHub is an account for developers. All kinds of developers have accounts in GitHub. GitHub allows you to do a lot of things. One of the things GitHub allows you to do is to collaborate. You can observe that most of the projects we are doing on Collab, you're working alone, but you can still collaborate on Collab. But there's a major difference between Collab and GitHub, which we will discuss as we progress. But GitHub allows you to collaborate just like Collab does. GitHub allows you to store your projects just like Collab does. Collab also stores your project. But where GitHub significantly differs from Collab is that you can store your projects in repositories which you can share and allow people to view. People can clone the project, people can work on the project, and there are so many things people can do. Now, collaboratory doesn't work like that. That is Collab. Collab, you simply share a link. So people only have access to one project at a time and the project that you want them to have access to. But in GitHub, you have something that is akin to a personal library, a library of the projects you have done. so you can refer it to people. So you can have it like something like a repository or like a CV of some kind, like a technical CV. You can reference somebody and say, "This is my GitHub account. Go there and see my works, see all that I've done over time." So it's very, very important when you're scouting for opportunities. Most times, if they want to see what you have done, they want to gauge your capacity as a technical person, they would usually request for your GitHub account. So that being said, let me sign into my GitHub. Once I sign in, I enable two-factor authentication so it will refer me to my mail. Can you see my screen, please?
No, I can't see it.
Okay, let me share my entire screen since I'll be going to different parts. Yeah. So they've sent me a link to my mail. Hmm? So the next thing I will do is I will go to my mail. Let me change it to my personal account, and there will be a message from GitHub, which is this.
Sorry, oh, I
So
didn't get the process. Oh.
okay, let me start again.
Okay,
GitHub
please.
is like a login account. Don't worry, we'll log into an account, another account. So just follow me on this one.
Okay, okay.
This is two-factor authentication. It will not always be like that. It's like this because I enabled it. Otherwise, if I just put my password, it would have let me in. So that's just two-factor authentication, extra security protocol.
Yeah.
So I provide that code and it just takes me straight into my. So this is my GitHub account. Hmm? Now, what is most important or most relevant in one's GitHub account is your repository, which is at the left hand side of the screen. You see this lineup, these are my projects. Your repositories is a record of all the projects that you have done since you joined GitHub, both the ones you collaborated with people, the ones you did alone, the ones that people collaborated with you, etc. So this is a list of the projects that I have completed. If I want to access the project, I just click on it. Once I click on a project, it loads that project. So this is this project. It's a document um, forgery detection project. So this is my what is called a README file. It's just it tells an audience about the project that this is what the project is about. Now, if you look at the right hand side of my screen, it tells you the languages that the project was developed in. In my case, it was 100% Jupyter. If I use JavaScript and CSS, they will all appear here, and the percentage of each language within my project will be reflected here. Then there will be a README file which I would have created to explain to the audience what this project is about. So as you can see, there's an introduction telling the person this is what this project is about. Then there's a discussion of the data set which I use. This is the data set, updates, future directions of the projects, conclusion and key takeaways, etc. So that is a README file that explains this project in detail to the audience. Then right here you see this code, this green button. It's the code of my project. So all of these are codes written in Jupyter Notebook. Now these codes can be downloaded. If I right click here, you see I can open with GitHub Desktop. I can download it in a zipped folder and all of that. So essentially, GitHub is a repository. It's a platform that allows you to save all of the projects that you have done. It also allows you to work there just the way we have a Python, a Colab development environment. GitHub also have their own development environment which is powered by Git. Then GitHub is very, very good for collaboration. because you can store versions of your projects on GitHub. You can pull your own version of my work. For example, if me, you, and Chinedu are collaborating on a particular job, I can create the basic notebook or the starter notebook and upload it to GitHub. You can now do what they call a branch. You can create what is called a branch, which will now be your version of the project. And you begin to develop it from your end, putting your updates, managing it as the case may be. Chinedu too can develop his branch and begin to develop it and move along. Since we are working together, at some point we have to merge all of this to one. Now, what happens is that I can leave my version, which I'm working on, and look at your version and get to understand the updates that you have done and all of that. And I'll be like, oh, yeah, this is good. This is a good thing. Then I can say, okay, let us merge it to the main. And once you merge it, it becomes one project. So that way we can, with ease, work on the same project. And if our communication is right, we can merge it when we are satisfied with the updates that one team or one person or another has done on the file. I don't know if that is making sense.
Yes.
I will still give provide a material that we would use to go through Git. Now, just like everything I explained, let me use familiar Git term phrases to explain it. Now, there is something called a pull request. A pull request, okay, first and foremost, I can come into GitHub. Like right now, I'm GitHub. I can decide that I want to create a new project. Hmm? So what I do is I go back because I'm inside the project now, document forgery. I can go back here to my homepage and I can decide I want to create a new project. If I click on this, I have created a brand new project. Let me click on it. This is a new project. And I'm being asked what is the name of my project? What do I want to call my project?
What do you know?
Then I can also provide, okay, Chinedu,
Sorry
you're
for
welcome.
interrupting. Yes, sir. Continue, please.
Yeah, I can provide the name of my project. I can also provide a description for my project. I can decide whether it will be public. If it's public, anybody that comes into my GitHub page can see it. If it's private, I must send invitations to people for them to be able to view it. So I can decide that as well. I can add a README. I just explained to you what a README file is. Then I can immediately begin to upload. Hmm? So once I do that and confirm creation, I have created a new project. I think for the purpose of illustration and for the purpose of this project, let's go ahead and create a new project that we are going to use for this task. This is the name of our project that we are working on, our work today, logistic regression. So let me create a repository from this logistic regression. Now, this is, I'm the owner of the project, so this is my name. The name of the repository, I want to call it classification, logistic regression classification. Hmm? It's telling me the name is available, no other person has used this name, so I'm fine to use the name. Then the next thing I need to do is to describe the project. So I would describe it as a Python classification project using logistic regression. Mhm. So that is how I've defined my project. Then I decide to set it to public so that anybody can see it. Then I can add a README file. Let me just start the README. Let me just start it. Then later on, I will update it accordingly. So there's a README file added to it. Once I click on create repository, it creates that repository for me. Okay, guys, please let me ask a favor. I think we should do this as a course on its own. Let me just go ahead and take my time to explain this gig in detail to you guys so you get to know it. We would concentrate on treating this logistic regression. The notebook is already here, so we'll concentrate on treating it in the next session so that we get this for projects in Git. We now have this as a repository. When you talk about repositories, you can have tens or hundreds of repositories. You work every single day, you create a new repository. You can have as many or as few. But if you are good at your, it's very, very tempting to do your development work in Colab. But I strongly encourage people, if you want to be a serious developer, either you migrate your project to Git. I'm guilty of that, guilty as you update your Git profile. On Colab, I have more than 150 projects. But on Git, I don't think I even have up to 30 projects. The best thing you should do is to always update your Git so that anytime you refer someone to your Git, it's your portfolio. Hello, Ruth, are you talking to me? Okay. Every time you refer someone to your GitHub, that is your portfolio. The person gets to see what you're doing. Now, there are two ways you can interact with GitHub. The first way is through the command line interface. Hmm? Through the command line interface, that is a very, very code centric approach. That is a good approach, but I think we should start from the easy approach, which is to use their very, very handy tool, which is a software, a graphic user interface based software, yeah, called Git. So I have it downloaded. I will encourage every single one of us to download it. So let me just open it so you guys see how it works. GitHub desktop. This is the setup, so you can download it and run it right after this session. Once you run it, this allows you to synchronize what is happening in GitHub on your desktop. As you can see, it has opened. Hmm? So it's just telling me that it can't find certain documents. And I know why I can't find it because I have relocated that document. I will correct that later. But let's, okay, let me see if I can even do that now. So I have, it's just telling me it cannot see a certain document. Okay, okay, I had copied it out. I had copied that document in your desktop. So once you have a copy in your desktop, anything you do and update, it will be updated on your remote account as well as on your desktop. As you can see, it's copying the items. There are about 54 items, which is about 10 MB or so. So it has finished copying the files right now. It's refreshing your repository and all of that. Now, if you're using the command line interface, all of these things you do them with commands. You do git clone, you fetch with a command, you clone with a command, You change the repository with a command, you rename the repository with a command, and so on and so forth. But this is a handy tool that makes it easier for you to do all of those things without necessarily working with so much code. Now, once this has happened, it has taken that document and kept it somewhere. Hmm? As you can see, this is the project. This is where it has deposited the project. Yeah. So this is the link to my GitHub account. Anything I want to clone, I can clone it into this place by default, or I can clone it to anywhere else. But this is the default folder that has been created for Git. Now, let me show you how this works. When you begin to write your code, for example, I have created a project which I called logistic regression. And this is the project here. Now, let me do this. Okay, first, let me first clone logistic regression to my system. Let me first clone it. I can come here and look for logistic regression. Okay. This is it. Share see logistic regression and classification, which is the project I just created. Huh? Are you guys following? So if I click on it and clone it, what happens is that it immediately begins to clone the contents of that folder to my local machine. Hmm? It has cloned it. So if I come here now and check, I'll see logistic regression here. Look at it. Hmm? It has created it on my desktop. And it has also shown me the README file, which I just put only the title of the project and nothing more. Hmm? So this is my README file. I can populate it accordingly. So let me give you a typical example of what is happening there. Let's say I come here and begin to explain what logistic regression is or what my project is about. Let me say I begin to say, sorry, it may not be intuitive. I just want to show you how this works. This is a cargo project to classify the events of the Titanic. Let me make it a header too. Mhm. And let me make it bold, right? Remember our markdowns. So I am doing this in markdown. So I will save it. Let me close it and save. Now it has saved. Remember that in my Git account, I still have this, but if I go to my README in my Git account, look at what it is. It's just what it was, a Python classification project, logistic regression. Now look at what happens when I pull, when I push. Let me go back here and push. Fetch origin and commit. Let me commit now. I'm pushing now. When you're pushing, you're sending what you've done in your local machine to Git. When you're pulling, you're taking what is in Git to your local machine. Hmm? You pull when other people make updates on the project and push when you have made an update. So let me push what I've done. Remember what I've done, I only worked on the markdown. So it's pushing now. Once it has pushed, it will notify you that it has currently pushed. So it has finished, it has pushed. It's telling you there are no local changes, which means there's nothing new that was uploaded or downloaded from that repository to your system. Only your system actually sent something to the repository. Now take note, this is what is here. If I refresh this page, it will give us the updates that has been done. Let's do it so that you see. I'm refreshing. Sorry, it's taking some time to process. I don't know, probably the network. Okay. So as you can see, it has updated. Yeah, you can see the updates. Can you guys see?
Yes.
Hello. Okay, so you can see my screen clearly. Can you see where the update has been affected? This is a Kaggle project to classify the to run the classification of events. That's what is written here. If you can see it, let me see
Mm-hmm.
if I can make it display as a proper readme so that you get to see. Sorry, this thing is being crazy slow. I don't know what's wrong with GitHub because it's not my network. If it was my network, it would have been affecting the network. It's GitHub that is just being crazy slow. Yeah, sorry about that. So so let's look for our logistic regression. This is it. This is our repository. So you can see it has updated. This is a Kaggle project to classify the events of the Titanic. So let me do another thing again just to show you how it works, how you can commit your codes to. You can see there's no code in that repository. You can see, right? The only thing that is in this repository is the README file. There is nothing else in this repository, so it's an empty repository essentially. Now you can if you have finished working on your code, like we have finished working on this code on our local machine or on Collab, and we want to send this code, we want to push it to our Git. What we do is that we come to File, we save this code, we download it as IPYM.
It seems your network is breaking now.
So you
Hello? Hello, coach.
come into it,
Hello? Hello?
come into
Hello?
logistic regression and save here. What you
Hello?
have
Can you
done is
hear
that you
me?
have added something to the logistic regression.
Hello? Can you hear me?
Mm, oh, I'm sorry, but you can see,
Please, your
yeah, I can hear
network.
you. Can you hear me?
Your
See the
network.
confirm? Yes.
I can't get you properly. Your network is breaking. So the major points I'm missing out on them.
Okay. Okay, Ruth.
Yes.
Ruth, I think the recording is going smoothly. Hmm? I
Okay.
don't.
Okay.
Yes, so you will get the missing parts from the
Okay.
recording. Yeah.
Okay. That's fine.
Mm,
That's
sorry
fine.
about that. But I was trying
Okay.
to just show you how the GitHub repository is updated. So now we have downloaded this notebook. We have downloaded this notebook into our local repository folder, which which is this. So you see now there's a notebook and there's a readme file. There's something to commit now because there's a difference. So we can push once we push this, it will update our GitHub repository and add this new code that we have just added, this Jupyter notebook. So let me run it. I'm pushing the origin, so it's pushing our Jupyter notebook to our GitHub account. Yeah, it's taking a while because the file is a little bit on the large side. So it's running it. Once it's complete, our Git will be updated. Fine, it is complete now. Yeah. So if we go back to Git at this point and check, remember we did not have a Jupyter notebook in our Git account at that time. But if we check now, if we refresh Git, you will see that a Jupyter notebook has magically appeared. Not magically, we pushed it into it. So this is our Jupyter notebook now. Can you see it? Logistic regression classification. Can you see it, please? Ruth, please confirm that you can see it.
Yes, I can see it.
Okay, great. So that is how it works. And you can do almost anything. You can push, you can pull, you can. It's beautiful when multiple people are working. For example, now I've pushed this folder. If you were a part of this project, if I add you to this project, which I can simply do by going to my home, let me just do that so you see how I can add people to a project or how you can add people to your project. If I come to the repository, which is logistic regression, in fact, I think I will add you guys to this project. We'll use it to learn classification. Okay, this is our project. Hmm? So here it has opened. Hmm? And it is okay, it's a public project, so there's no need to add. Everybody is automatically added. Once your project is public, everybody is in the project because anybody can come from nowhere and download your project. They may not be able to modify the project, but they can do what is called a fork. That is to get your work, to create a branch of your work and begin to develop it from that point. So let me do something. Let me set the project to private. That is, oh, I hope I can remember how that is done. Hmm? Okay, let me not waste too much time. I don't have that on my fingertips, but I will do that and I'll show you guys how that is done. If we had created the project as a private project from day one, it would have been better and easier. But yes, we can convert a public project to a private project. And once we do that, you can now decide to invite people. Now that's where GitHub gets very beautiful because I can now invite you personally. If I don't want, it's not a public project, I don't want all and sundry to be able to view my work or know what I'm doing. I can now invite you using your email. When you come into the project, you can create your branch. So when you create your branch, you finish doing everything, you can constantly update your branch. And when you're satisfied, not just you are satisfied, and I am satisfied with what you're doing, the whole team, we can merge your work to the main. So the first one I created is the main, which is this one. Hmm? Now, if I create a branch, automatically I have a branch. That is what I'm working with on my local machine. If I add you to this project and you create another branch out of this this code to start working on it, you have also created your branch. If I add Chinedu and he creates his own branch, he has also created his branch. And the same way you are working on it, you can also work on the README file. For example, you can look at the README file and say, okay, I can enrich this. This README file is too simplistic. I can add stuff. Now, observe something. I can work on the README file here. I can also work on it on my computer, on my local machine. So let me work on it here so that you see. In the same way, I can work on the code there and here as well. You know, GitHub has its own code editor. I think it's based on it's based on this product by Microsoft. I've forgotten what it's called now, but it has its own code interpreter that it can use to run codes. Yeah. So let's say I come here and I add we are collaborating effectively on this one. For example, I've added this. Hmm, let me make it bold as well. Now, this is in my Git. I can commit it. Once I commit this change, I have locked it in. So it has edited it. This is my README now. Hmm. Now, if I'm on my local machine and I do a pull request, it will tell me that there's a difference. Look at fetch origin. This is what I would use. Once I click it, it's going to my GitHub profile and it's fetching what is there. Hmm? It has now told me that there is a difference between what is on Git and what is on my local machine. And it's asking me, do you want to pull? Which is this. So if I just say pull origin, it will pull whatever is on GitHub and synchronize it with my local machine. So at this point, I can come to my machine and check. You would see that what is here in my README file has updated. We are collaborating beautifully. Now, this is just small changes, but this thing works for massive changes. By the time you begin to edit lines upon lines upon lines of code, you begin to change. So it makes collaborative work seamless and easy. Hmm? So I think that is basically it about Git. So what we're going to be doing, every single project we work on going forward. In fact, good a thing we have not worked on the last project. I think starting from that project, as we begin to work on it, please let us upload them in our Git profiles. Not just that, let us collaborate. There are projects I will encourage you to do alone, but as many as you can, involve me, involve Chinedu. Let all three of us be a part of your work. It makes it look more professional, like if there's teamwork, there's interactivity. So that being said, I think we have covered it exhaustively today. You can pull, you can push, you can create a Git repository, you can fetch from the Git repository, you can rename your repository, you can set it to public and set it to private. So that is enough of a start on how to use Git and how to run with Git. So please, Ruth, are there any questions you have? Please, I really encourage you to ask questions about things you do not understand. If you do not have questions, I'll have a couple of questions for you myself. So, are there any questions for me, please?
The question I have is that this bit, is it made for just collab alone?
Yeah, there are several reasons why Git was made, principally for collaboration. Everything Google Colab can do, Git can do. So Colab was in fact Google's response to Git. The only thing Collab did much, much better was compute. Collab allocates you a much more powerful machine than Git allocates. That's one. Then number two, Collab also allocates to you more space, but Git has a very major advantage over Collab, and that is in its presentation. Git allows you to have a repository that you can share with people. It gives you a platform to be able to showcase your work, to showcase your expertise. Collab does not do that. Collab is like walking in your closet, it's like training in a gym. Git is like walking around on a stage and showing off what you have, the muscles you have acquired by walking in the gym.
Sorry, if I understand you better, but if you're on collab, you can't share your work.
You can share your work,
Or you
but you
can, but
cannot display your work. Yes, you can
work,
share your
okay,
work
okay,
one at
okay.
a time. For example, you can share a link to a particular
A
collab that you're
link,
doing to
yeah,
me.
I get it.
That, and I
I
can
get
see
it.
only that. But
Only the
in Git,
link.
yes, in Git, I can come to your Git profile and see all your 30 projects if you set them as public. And I
Okay.
can go through them and I'll say, wow, this girl is a
Make
brilliant
some
data
changes.
scientist. She's
Okay.
very good at what she does. Yes. Then it allows you to add a README file. In short, you present it as a proper full project. You can put a README file, you can add your data set, you can do everything that you need to do. Remember, Collab does not have all that kind of leverage. Collab is just your notebook and Markdown. Finish. You cannot put
Okay.
your file there. You have to find a way to send your file to the person. You cannot put your markdown to explain anything about the origin, everything you need to do. Sorry, everything you need to do must be in markdown within your notebook. You cannot put a readme file separately. And these are very, very important for professional projects. You need to have a readme file that explains how to do things, how you process your work, how you process your data, and all of that. You need to have a notebook or a script. You need to have data or other dependencies. Sometimes you have more than one script depending on the nature of the project. So GitHub is a perfect tool to present such full scale project. It does a far better job than Collab. Then above everything else, recruiters, the people you're going to work for in future, that is usually what they want to see. They want it's like your they don't sometimes they don't want to ask you much questions. They just tell you, send me your Git, your the link to your Git profile. Let me go and look at your repositories and see the work that you have done. So another thing we needed to cover that we did not cover is best practices. Hmm? In writing your codes, there's a way somebody comes and just sees your code, and the person is not even interested in going forward. The person is like, no matter how brilliant this data scientist is, his work will be too confusing, his work will be too jaga jaga, as we say in Pidgin. So, there are best practices. Imagine your work as a work of art or an article. An article must be structured, must be neatly written. You must respect the laws of writing in English, proper paragraphing, proper spacing, proper capitalization. There's something called PEP 8 in Python coding where all those guidelines are given. So you must learn to write your code that way so that once someone comes and sees your code, they know I'm dealing with a professional. So when you're creating your projects in Git, respect all those rules. Part of what I'm going to share, I don't want to make that a session on its own. It will take too much of our time. So I'll share materials on PEP 8, that is professional coding, how to code as a professional. I'm talking about the lexics and the structure of coding now,
Okay.
not the
Okay.
content. So whatever the content is, however good the content is, yeah, the way you should present it, that's what I'm talking about, the packaging, the
Mm.
aesthetics.
Yeah.
So I'll share materials on that. It's called PEP 8 standard, how you can follow PEP 8 standard. I'm also going to share comprehensive material on Git. I will also share material on scripting in Git. But like I said, you may not focus so much on that if that will be so much of a time consumer. It's something you can learn gradually at your pace. But the GitHub desktop does a wonderful job. Almost everything you want to do, you can do there. You can pull, you can push, you can compare with the origin, you can do everything you want to do. Then within Git, just play with the tool. Go into Git, look at how things work. But bear in mind that going forward, you're writing your codes in Colab, you're updating it in Git. Make a habit of it. Immediately you want to start a project, just run to GitHub, create a repository for that project, title the repository, create a quick README file, and immediately start working. Please, our next session is also a very, very important session. Remember, I told you guys that I will teach you some tricks to make coding all these things fast. So next week is the time that we are going to talk about that. We're going to be talking about how you integrate AI tools with your work to make your
Mm.
work fast, to make your work
Uh,
efficient, and to bypass a lot of stress associated with creating your code from scratch. So next week is when we are going to do that because sorry, not next week, next lecture, next session. Because after that, what I want to see is project, 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 project. If I give you one project before the next time we meet, what I want to see is that you've done that project and you've done two extra. Most of the things that makes the thing difficult and slow for you. After next week's session, those barriers will be taken away and you'll be able to work with great speed. So, in line with that great speed, I want to also see great efficiency and great productivity. Sorry, we could not go into logistic regression as planned. We would have to reschedule it for another time. This turned out to be a very, very important session. I wanted to gloss over it. I didn't want to waste much time on it. But since you told me that you're not familiar with Git and you've never used it before, and considering the importance of Git in the work we are doing, I had to just do this. Yeah, take the time to explain it very well. I hope you do not mind, please. We're
no,
still going
not
to
at all. A good thing
uh,
you did this.
okay. We're still going to catch up with the rest of what we need to do. So at this juncture, I think we can call it a day. I would share these materials once they process this video and I have access to it. Sometimes Google takes so long to process the videos, I don't know why. But once I have access to the video, I'll share it alongside the other materials that we're going to be using, which is the materials for Git, the materials for PEP 8. PEP 8, even though you're not familiar with it, I've explained what it is. It's very, very easy to understand. It's simply the convention of how to write your codes in Python. We have done basic Python for data science. We are now going into algorithms. We still remain in algorithms. Then once we do AI, integration of AI into data science, you will be able to do lots and lots of projects by yourself to enrich your portfolio. Hmm? And right after that, we are now going to go into SQL. Then after SQL, we'll go into data analytics, and at that point, we can wrap up the course. Yeah. Thank you so much for the time. You do have a wonderful night.
Yes, sir. Thanks.
Okay. Bye bye.